Alrighty, with that, we'll go ahead and get started with our first session of Strand A today. So I would love to welcome Allyson Bieryla and Sóley Hyman, who will be discussing LightSound, accessibility for the 2023 and 2024 solar eclipses. Thank you both so much for being here today.
Wonderful, thank you. Sòley, I think, is going to share our slides.
Just 1 second.
Fantastic.
And okay, we should be able to see my slides. Can you guys see them?
Yes, we can. That's great.
Wonderful.
Right, good to me. So yeah, hello everyone. I'm very excited to be here. That was a enthusiastic introduction, and I'm very excited for the next 2 days. My name is Allyson Bieryla. I'm an astronomer at the Center for Astrophysics, Harvard and Smithsonian. I'm a white female with long brown hair, sitting in my office on campus at Harvard. My pronouns are she and her, excuse me. And I'm going to be co-presenting this talk with Sóley Hyman, who will introduce herself in just a moment. And the title of our talk is LightSound, Accessibility for the 2023 and 2024 Solar Eclipses.
Hi everyone, my name is Sóley Hyman. I am a second-year graduate student at the University of Arizona in Tucson, Arizona. And I am a white woman with long curly hair that's in a ponytail right now, and I'm wearing a black shirt. My pronouns are she and her. And so on the slide in front of us, we have the logos for the Center of Astrophysics, Harvard and Smithsonian, the logo for University of Arizona, Stewart Observatory, and the LightSound logo, which is a solar eclipse with a music note in it and the words LightSound in both Braille and English on a blue field. All right, so we are the first talk of this conference. And so to start off, we want to ask the question, what is sonification? So some of you may be familiar with the term sonification, but to make sure everyone's on the same page, at the bottom of the slide here, I have a cartoon image of the electromagnetic light spectrum. I'll get to that in a minute. But first of all, sonification is the conversion of data or signal into sound. And it has a lot of broad applications, and it can be used anything from astronomy all across the sciences and medicine, chemistry, biology, and even humanities. And pretty much the imagination is the limit of what you can sonify. And for astronomy in particular, what's exciting about sonification is that most of the universe is invisible to our eyes. And so as I mentioned, there's a picture of a cartoon image of an electromagnetic spectrum down here, and it shows the range of what we know as light from radio waves, which have wavelengths on the order of 1 meter, all the way to gamma rays, which are the highest energy light that we know and have wavelengths smaller than 0.01 nanometers. So what is light sound in particular? On the right here, we have a picture of the light sound, which is pointing up at the sun on a small little portable tripod. And light sound is a sonification device, and it converts ambient light intensity to sound. And it was designed for blind and low vision individuals to be able to experience a solar eclipse in real time by listening to the sonification of light as it descends and ascends during a solar eclipse. And so light sound is about the size of a cell phone. And in this picture on the right, we have a dark plastic case with earbuds coming out of it, and it's pointing up at the sun and sonifying the light. LightSound uses Arduino technology, particularly from the Adafruit company. And so it's very easy to program as you wish and incorporate open source code for it. And it's a very low cost instrument. It only takes around $60 to build, and also not very extensive skills, just basic soldering skills. So pretty much anyone can learn how to build a LightSound and use one. So on this next slide, I have an image from a plot taken from data from the 2017 Great American Solar Eclipse. It's a red line that descends and ascends like a curved V. And as I mentioned before, LightSound is an open source project. So that means you can download your own instructions to build. You can download the software to collect and plot the data. And you can download lesson plans that we're developing to teach astronomy concepts, all free of charge. And you can also develop them yourself once you've downloaded them. So that's very exciting. So how does LightSound work? On the slide right in front of us, we have a picture of a solar eclipse in the diamond ring phase, which looks like a dark black disk with kind of a gauzy halo around it and a flare, which is the diamond ring as the sun and moon enter the solar totality phase. And then light from the sun comes down and reaches the light sound on Earth, which we're observing with. And inside the light sun, so now I'm showing a picture of the interior interior of the LightSound, it's a black box with a bunch of circuit boards in it. We have a sensor which processes the light and measures how bright it is. It sends that information to the Adafruit Flora microprocessor, which is a circular circuit board. And then it determines what pitch is going to be played and what instrument will be played with that. It sends that to a MIDI synthesizer, which is a blue rectangle beneath that circuit board. And then that MIDI synthesizer generates the sounds and sends them out an audio jack to our ears, which we can hear either through a speaker or headphones. And there are 4 different sounds LightSound plays depending on how bright it is. So right now you just heard a couple clicks that happen in dark or indoor light. So in that range of light. In indoor to daylight, you just heard an ascending clarinet. And so that's kind of indicating mid brightness light. In very high brightness light, when you're outside in daylight, you've just heard a flute. And in very, very bright light and extremely bright sunlight, or when the sensor is saturated, you hear a plucked string. LightSound also has a micro USB port that you can connect to a computer either for power or for data. And right now on the screen, you're seeing a picture of a graph of the data collected from one of the solar eclipses with that typical curved V that you see during a solar eclipse.
Okay, so I'm going to talk a little bit about LightSound at various events that we've used the LightSound at. And so I think the image is being clipped by, there we go. Excuse me. So as Sòley mentioned, the original LightSound was designed and developed for the 2017 Great American Solar Eclipse. And it came to be by conversations between Wanda Diaz-Merced, who's a blind astronomer, and myself when she was at the CFA during her postdoc in 2017. And she was getting ready to leave for a teaching position in South Africa. She was going to be teaching a group of blind students. And if you remember from the 2017 eclipse, there was international really hype. Excuse me, sorry about my voice. International hype about the eclipse. And so she really wanted to be able to have her students participate and have access to this event as well. So we discussed how to make it accessible. And after many conversations, we came up with this idea of the LightSound. And so we had built 3 devices for this event. And so I'm showing a map here of the United States with 3 pins. The one on the left is in Jackson Hole, Wyoming, which is where I was. And at that event, I streamed the sound of the event via the web. So Wanda and her students, who are pictured in the top left in an image, were able to listen from South Africa, and other people around the world that weren't able to attend were able to listen as well. And then we had 2 devices in Kentucky, and Sòley has already described this plot, which is shown here again with the descending ascending curve, V shape, was collected from our colleagues at Morehead State University. So this was kind of our proof of concept. It worked. We were able to stream the sound, and we were able to collect data. So next slide. There we go. Okay, so then we were looking ahead to the next event, which happened in July 2nd, 2019 in South America. So this was an event that was going to go through Chile and Argentina. And so we were able to be funded by a grant through IAU special grants to build and distribute 20 devices across Chile and Argentina. So we partnered with our colleagues Beatriz Garcia in Argentina, and then Paulina Trancasco Iribarren and Erica Leib in Chile. And we were able to distribute these devices along the path of totality. And there's an image here of the map with red pins showing spots across Argentina, and then blue pins showing spots that we distributed them in Chile. And so these were places like museums and observatories and libraries, universities, all over, wherever people were going to be holding events to try to make these more accessible. And as part of this project, we also were able to translate the instructions to Spanish to make it more accessible to those in South America. And this is where we really started to think about lesson plans and teaching these concepts of light outside of just eclipse events and at eclipse events. Okay, next slide. And we got a ton of feedback. We got like pictures and comments. And I think the biggest takeaway was that one single device can impact thousands of people. So this image on the left is probably my favorite image. It's an image of La Portada Stadium in La Serena, Chile, where it shows thousands of people. It's a huge stadium. And in the forefront, there's a group of blind individuals, and on the table is a light sound. And the light sound's connected to a very large speaker. And so this one $60 device is making this entire event to those that need it accessible, which is just extremely rewarding to see and hear positive feedback. And the image on the right is a young man who's holding a cane and a light sound in the other hand, pointing it up at the sun, listening to the sound and being interviewed. And that's in Santiago, Chile. So this next slide is a video clip. So we want to play you kind of a simulated version of what you might expect during an eclipse. So here it's just an individual holding a light sound, and the light sound is orange in this case. So previously we've been showing you the United States cases, which are black. This is now a 3D printed version from our colleagues in Chile. It was easier for them to 3D print them than to ship cases to Chile as they started to develop more. But the insides of this case are exactly the same as Sóley described. So here we're going to play a clip in just a second, and what you're going to see and hear is there's a black circle that's going to cover the sensor, and as it covers the sensor, you're going to hear the change in sounds, and I'll kind of describe that as we go. So this is a high flute pitch, so full sun. It's going to start eclipsing. This is the clarinet sound, and then very low clicking and full totality. And then we're going to come out the other end here and you'll hear the reverse. The clarinet, and then the high flute sound again. Okay. So then there was a second event in South America in December 14th, 2020. And for this event, we were a full pandemic, so it was a little different than normal, but we redistributed the 20 devices that already existed in Chile to those that were going to have events. And the event was streamed live on YouTube, which was very exciting. And again, we're showing a map kind of with pins for locations, and we kind of list them here. I won't go through all of them, but again, it's museums and universities and libraries, et cetera. But the very exciting part of this is our Chilean colleagues also got funding through ESO, Gemini, and a number of other sponsors, and were able to build over 100 more devices. So they were also distributed all across Chile and Argentina. So the project just continues to grow. All right, next slide. I'll just show a few photos from the events. Argentina here, we have a light sound device on a portable tripod, again on some milk jugs, just listening. And then in the middle, we have an individual and a man in a wheelchair holding a light sound up to the light, listening with earbuds. And then on the right, we have a child listening to the light sound through a speaker. And in the top left, we have an image, a plot of the intensity of light over time as the eclipse happens. So folks were also collecting data at these events, and Sòley was made a very awesome sound map, and that's available on our website. Next slide is just a few photos of the Chilean event. So again, we just have a few individuals showing off the different colors that the 3D printed cases are, yellow and purple. We have a child on the left holding it up with headphones listening, and then the middle, two girls doing the same. And on the right is just an example of this kit that I was telling you that I mentioned. LightSound was part of this larger kit that was distributed across Chile and Argentina through the grant from ESO and Gemini. All right, next slide. And so this was also briefly mentioned, we're developing lesson plans that can help you use this tool, not just at an eclipse event, but also in a classroom or an outreach event to demonstrate these concepts of light. This image here on the right is from our lesson on orbits. So we have individuals holding what looks kind of like a hula hoop and a bright light shining on them, and the light sound is detecting changes in light. And again, really just one device can teach a whole classroom with these lesson plans. All right, next.
All right, so I'll take over from Allyson here and talk about preparing for the future. And so Allison's talked a little bit about previous events and what we've done, but I also want to draw some attention to some exciting eclipses coming up across the Americas in the next couple of years. And so in about 2 years, a little bit less than 2 years, there's an annular eclipse going across both North, South, and Central America on October 14th, 2023. And so I have a map of the two Americas with, of three Americas, I guess, with the path of the eclipse going through them. And I'll talk about where that path goes in a second, but also on the bottom left, for those who aren't familiar, what an annular eclipse is when the moon doesn't fully eclipse the entire disk of the sun. And so it kind of gives this ring of fire appearance. And so what it looks like is this dark black disk with an orange circle around it, which is the uneclipsed part of the sun. And so right now I have a close-up of the map of the United States with the path of annular eclipse going through it. And I just want to draw some attention to the locations of note for people in the audience who are going to be living in those places or near those places during this time and may be interested in using light sound during this event. And so there are several US states affected, particularly Oregon, Utah, Colorado, Arizona, New Mexico, and Texas. And because this is out in the west and southwest part of the United States, there are lots and lots of national parks, recreation areas, and monuments affected. So over 11, and just briefly, I'll list them: Crater Lake, Great Basin, Capitol Reef, Canyonlands, Glen Canyon, Bryce Canyon, Natural Bridges, Mesa Verde, Chaco Canyon, Bandelier, and El Mapai. Now I've got a picture of the map from South America and Central America showing the path of eclipse. And there are quite a few countries that this also crosses. So just to make note of those countries also, in Central America, we have the Yucatan Peninsula of Mexico, Belize, Honduras, Guatemala, Nicaragua, and Panama. And then in South America, we also have Colombia and northern Brazil. So it passes through Amazonia, right past Bogota in Colombia. And this is very significant because it passes through many large population centers or capital cities. So these are areas we might want to consider if you know people or institutions that may be interested in using this. This is an exciting way we may be able to reach people and teach astronomy and help people experience this event. In 2024, April 8th, 2024, there was another eclipse passing through North America. And I have a picture of the map of the eclipse. I'll talk about that in a second. And a picture of a total solar eclipse on the bottom left, which is, again, that dark disk with kind of a gauzy halo around it. And so this is a very exciting event, especially because it's crossing through very large population areas in the United States, through Texas and the East Coast. And so just kind of, again, to note important locations, there are lots of US states in totality, including Texas, Arkansas, Missouri, Indiana, Kentucky, Ohio, Pennsylvania, New York, Vermont, and Maine. And as I mentioned before, there are lots of large population areas in or near the path of totality. So if you live in this area, stay tuned and maybe reach out to us if you're interested in using light sound. And also I should mention in Mexico and Canada, there's also totality in several parts of those two countries. In Mexico, there are 3 states in totality, Sinaloa, Durango, and Coahuila. And it's a partial eclipse for the entire country. So lots of people can participate with this. In Canada, there's totality in over 5 provinces, particularly Ontario and Toronto, Niagara Falls area, Quebec, Montreal area, New Brunswick, Prince Edward Island, and Newfoundland and Labrador. And so in preparation for these events, Allyson and I have been running a series of workshops. In the bottom right here, we have a picture of 2 participants soldering and assembling one of their light sounds that they built in this workshop. And so we've hosted workshops so far through the American Astronomical Society, both this coming January 2022 and in January 2020. But we're also planning to host workshops for educators and general community members and organizations, particularly libraries, national parks, schools, et cetera. And we're trying to both teach people how to build light sounds and also train people how to run light sound workshops to teach other people how to build them.
Right. And yeah, just to kind of end here with the partnerships, that Sòley just mentioned, we really want to grow the project. So as we look forward to 23, 24 in the United States and Mexico and all the locations that Sòley mentioned, we really need an army of people to help build light sounds, to help run these workshops and, potentially donate. So like having a group build them and then donate them to communities in need. We're exploring all these ideas and looking forward to this and looking also forward to kind of developing maybe a kit kind of similar to what they did in South America. So last slide, I think. And I just want to mention on this one slide, there's a second device that we have called Orchestar. It exists, but it's still under testing and development. And it's essentially looks the same as the LightSound. Many of the components are exactly the same. The main difference is it has a color sensor instead of just this high dynamic range sensor that LightSound does to detect a change in light. The Orchestar detects change in color or change in wavelength. So you can detect like red light or blue light. And then this photo on the left is showing an individual with a LightSound. There's an option to turn on an LED light. And so he's holding it up to a poster with a color map. And basically as he moves along that color map, he can detect the color on the poster. So it's detecting reflected light off of that poster. So blue or red or yellow. Right. And then our last slide here is just, it shows our logos for LightSound and Orchestar, has a QR code and our links to get more information. Also Sòley and my email. And we look forward to hopefully hearing from some of you, collaborating with you, and thank you for listening. We're really excited to take any questions you might have.
Amazing. Thank you both so very much. We do have about 5 minutes. So thank you for that fantastic presentation starting off our conference. And we'll take questions using the Q&A. So please feel free to type your questions in there and we'll go ahead and go through those. So first, I see a question from Lisa who asks, when developing the kit for data sonification, do the sounds remain consistent with the instruments, such as the flute, clarinet, etc.?
Sòley, do you want to take that since you did a lot of the work on the sound?
So if I'm understanding correctly, the range of, and correct me if I am misunderstanding the question, but the range of pitches for the various instruments, the clarinet is a lower register, the flute is a higher register. So they don't jump around on pitches, it's more of a continuum. The reason we're using different pitches is so it helps the ear cue into whether it's high light or low light. Because if you're listening to it for a long period of time, it's easier to get confused, whether how much it's changed over time.
Amazing. Thank you. Next question we have here is from Adrian, who asks, are there any possible connections with FIRST Robotics?
I'm not familiar with FIRST Robotics, I don't think. Do you?
So I am a bit familiar. We don't have any connections right now, but as Allyson kind of highlighted in one of our last slides, this is something we'd love to do. We currently, the people who are building it in the US are mainly Allyson and myself, and we can't obviously service an entire country. And so if you have organizations that may be interested in building these devices and donating them, or even holding like workshops to teach underserved communities how to build them, because soldering is such an important skill to know how to do, we would be more than happy to reach out and try to make some partnership with that.
Amazing. And I believe one of our presenters, Harry Wood, later today will be discussing FIRST Robotics and outreach he does with deaf students doing robotics and coding. So there may be some interesting connections to his work that he'll be sharing this afternoon. Next question is from Wendy, who asks, possible next step for making haptic interface for LightSound for those with both vision and hearing impairments?
Yes, yes, we have been talking about this. We have the parts. We are anxiously waiting to put them together and start testing that. We definitely are thinking that way.
Amazing. Yeah, I'd love to see what that would look like. It's a great idea. Next up, Sahil asks, what's the average cost of building one of these kits? How do you plan to make it more widely available outside of North and South America?
Yeah, so the LightSound costs about $60 and Orchestar $75 to $90. Some of this depends on the case, right. So this project isn't just those that can build and make their own cases. We definitely want to serve communities and people that don't have the ability to do this, and that's, I think, where we're going with partnerships and grants of like building and donating some of these devices to communities in need, and going and doing workshops in communities where people can learn how to do these and then spread that knowledge.
And also to make one other point on that, we've also had some people not affiliated with our LightSound project directly build LightSounds in other countries. So there was an Eclipse in, I believe it was Indonesia or Malaysia a couple of years ago. And they had reached out and they had built their own LightSound and actually broadcasted that on YouTube and stuff like that.
Amazing. Next, we have a question from Lisa, who asks, is it possible to use the data sonification instrument for color coding of maps in ocean seabed floor?
Waiting for Sòley to say something.
Okay,
I don't know. We haven't. Yeah.
Certainly, you can any colored image. You can use Orchestar, probably not LightSound to sonify it. So you can use Orchestar for color sonification. But if you're trying to do, these are more as a general outreach tool, and so they're not meant for high quality scientific data currently. So there are other sonification, packages that you can probably use if you're trying to actually do research with that.
Fantastic. And one final question here, similar, Adrian asks, can light sound be used in other situations? So kind of similar line of thought to Lisa's question.
Allyson, do you want to take that?
Yeah, I mean, it can, and that's the thing. We were thinking astronomy and thinking eclipses when we developed it, but I'd love to hear feedback on what you think it would be useful for. So we're definitely open to that, and we've mostly been thinking astronomy, but I'd love to hear what others are thinking it could be useful for.
Awesome. And we will take one more question here, and then before we transition, this one asks, is knowledge transfer possible for this project? I would love to build these devices and donate it.
Yes, we definitely want to train others, teach others how to build these, how to do these workshops, and that's the only way. It's going to take a large group of people to make this possible, and to build a ton of these devices that we'll need for upcoming eclipses, and to get everyone this for teaching and outreach.
Fantastic. And as we get additional questions pouring in, Allyson and Sòley, feel free to type answers in the Q&A feature. So you're more than welcome to respond that way. But I want to thank you both so much for your fantastic talk and for joining us today.
Thank you so much.
Thank you.